Good evening, gentlemen. Today we're going to be talking about the stereotype study that we have recently published in none other than OpenPsych. And why don't we just get to it? The study itself, well, it's very long, so there is this abstract which you may pause to read, or you may just keep going with the video as it is as you please. So it may be the most complicated stereotype study today, and I put the index of the paper here, and you can see it's 51 pages, which includes a bunch of a appendix or things that come after the paper stuff. And hopefully we'll be fast in the future because this project just took too damn long. The data, this is a study about Dutch people or Dutch data in general, and we sought to sample 500 Dutch citizens using the Prolific software. Unfortunately, they didn't have enough Dutch people, and so we only got 411 after filtering for data quality. A lot of people, they skip stuff and so on. So you have to filter a lot by quality. Anyway, so 411 subjects with valid data. And because we had the planned sample size of at least 500, we then sought a different company survey to sample another 200 students, or 200 subjects, that is. And the reason we sampled 200 instead of merely say 100 or so, or 90 to complete the sample size, that is because we wanted to compare the two data sources. And pretty much we collected the same data from these, and after cleaning stuff we end up with 615 valid subjects. And the subject, the questionnaire itself, the survey, took roughly 23 minutes to complete, and you can see it has some 60 questions. So it's quite large. Maybe we need to do full screen. Okay, yeah. Let's do this. So the survey, what does the survey have? So these are the pages of the survey, which I just looked up now. And consent, blah, blah. Consent is sexy, right? And confirmation of citizen, blah, blah, blah. So when you sample data on Prolific, they give you a bunch of variables for free. And that's because on Prolific, they ask their participants tons of stuff, education level, parents are born, blah, 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 which language do they speak. So all this data you get for free whenever it is you get any participant, and you can use that to filter which subjects you want, which may be kind of relevant to whatever research you're doing. However, since the other company did not provide the same variables, we had to ask some of them, and that's what this page 3 refers to. Page 4, we asked about some education stuff, mainly kind of like trying to classify into people into how high in education they finished, whether it's university level or some kind of non-university, and beware. I remind you that this is in the Netherlands, and so their system is a bit different than say the US one, and so things may not be quite so simple. Family background, voting, blah blah blah. Interesting for this, we wanted to have two different intelligence tests. We had a vocabulary test, and it's a homemade one in the sense that we made it, and it's based on the online vocabulary test at the website you may know, Open Psychometrics. They have a vocabulary test. It's pretty good. It works they show you 5 words at a time, and you have to choose the two ones that are the best, the closest to being synonymous in the same meaning. And so we made these, or that is my co-author, Arjen. He made a Dutch copy of this test, and it works fine. Secondly, we had the science knowledge test, which is also homemade. We used we came up with a bunch of science questions, and we asked them to choose the right one. So the intelligence was simply scored as a G factor of these from item response theory. Then, page 9, we measure stereotypes by occupation. And so here, what we do is that we essentially ask them like this. We show people a list of occupations, and these come in random order for each person. So the next person here will not have a docent in the top. They will have maybe journalist or some other ones. And there are 54 of these. There's a lot of occupations, and the reason for the 54 occupations is that we wanted a very broad distribution, where some are very female dominated, some are very male dominated, and they are quite representative. We were able to find data from the Dutch government about the actual distribution of these jobs, and so we have perfect reference data, so to say. And as you can see, each person had this, they had a slider, and they had to do their guess of which percent of these people are which sex. And then the next page, which I guess is 10, it looks like this. In Dutch, it says blah blah, a lot of immigrants. These immigrants may have different crime rates, and they come from this list of countries, which there are like 70 or so, yeah, 80, 68. And the reason for the 68 is, again, before we had crime data for these countries that we had a prior paper on. And so we used those, and we asked people to estimate the relative crime rate. And so the relative crime rate is where the Dutch crime rate, the home Dutch, the actual Dutch people, is 1. And so for the other ones, you have to guess how many times more criminal. And so, for instance, if you think they're half as criminal, then you should pick the number 0.5, which will be here. And if you think they're twice as criminal, you should pick the number 2, which is over here or so. And you can go all the way up to 10 or 5 or so. We wanted kind of the scale. So ideally, of course, no one should pick 0, since no group has no criminals. And it wasn't plausible to have values much more than 10. You can argue about not using a slider here, and instead of having people to put a number in, but that would make the survey longer and harder to do on like mobiles and this sort of thing. And so it's a bit difficult. You have to make some choices when you design these surveys, and we went for this choice. We've previously shown that we've tried estimating stereotypes in different ways for various things, and it doesn't matter too much exactly how it is you exactly phrase the question. Maybe one particularly nice way you make the accuracy become 0.1 correlation higher or so, but in any case you get more or less the same. For provinces, we did in fact use the number input, and in the Netherlands they have these provinces. I guess there are 12 of them, and for each of them they have to guess the disposable income, or disponible as we say. After you've paid your taxes and your normal expenses, then you have some amount of money left, and we ask people to estimate this amount, and that's because the government gives you this data. And so we wanted people to see, we want to see how closely people could get this right. So recap, I've done some other stereotype studies in the past, but let's go over how it is you actually calculate these accuracies. And so in table 1, what we have here is we have an example where we have 3 people, A, B, and C, and they are estimating some kind of unit, and they're estimating them for the targets X, Y, and Z. And for these, they're trying to estimate the value of X, Y, and Z. It could be the mean height or mean income or mean crime rate or whatever. It doesn't matter. And they give these numbers. So rater C, he's rating Y to have 16 and 17 for the other one and 15 for X here. And B has some different numbers. And then for each target, you can take the average, and this is the average guess in this case. Over here, you can calculate the deviation, which is the true one, the true value divided or minus the estimate. And so 5 should mean that you got the value estimated 5 too high. And you can see the true values are down here, 10, 20, 30. And so this value is 5 because this one is 15 and this one is 10. 15 is 5 too high from 10. And so on. You can get these numbers. And again, you can also get the numbers from the means. How far away are the means? So with that said, that is how the stereotype data looks like. It looks like raters on rows, targets on columns, and you can calculate the deviations and so on. If we then look in terms of the statistics down here, we have for instance, the Pearson correlation. So we simply correlate these 3 values with these 3 values, and that gives you this result. And these. So you can see actually here that the Pearson correlation for rater C, that's this guy, it's 1. So he got the correlation accuracy was perfect. And the Spearman is concerned with ranks, just getting the rank order correctly, not necessarily the distance or so between values. It's also perfect. And you can see why. It's because C said it's 15, 16, 17. And so that is the correct rank order, and they're equally distant, just like 10, 20, 30 is equally distant. Of course, the viewer is now thinking that, yes, they did rate these, but these values are quite far from the true ones. That is true. So for instance, what you can say is that we can look at the mean estimate for C, which comes out to 16, and the true mean is actually 20. So we can say that C was 4 too low on average. And it's the opposite is the case for rater B here, who was 4 too high, and A was 6 too low. And so you can have a mean error, and that's how much you tend to over or underestimate everything in general. The other way you can do it here is that you can calculate the standard deviation of the estimates. And here we can see the problem with C. His standard deviation is 1. And however, the true standard deviation is actually 10. And so he was 9 too low in the standard deviation. C was massively underestimating the real differences in terms of size, even though he got the rank order and the relative distances correctly. And so he gets a very high negative standard error or standard deviation error here. And the mean absolute deviation, that is simply taking the mean of these values, but as the absolute value, so removing the minus signs. And so that is how far your guess is away from the truth on average. The mean absolute deviation. I guess the other normal name is mean absolute error, but so just to go to the big picture, if you take the crime rate data and you take the average for each person, you get this kind of plot. And so the overall accuracy is 0.65, which is quite high, and that's across these 68 groups. Of course, that is highly statistically significant, which you can see because these the standard error. This is not the standard. Sorry, this is the confidence interval. The 95 confidence interval is not remotely close to 0. So in that case, the p-value will be very small. What we see here, the stippled or the dashed line here is the perfect calibration line. And so what it means is that if the stereotypes are estimating crime rate to be 2, then the real crime rate should also be 2. They should have a slope of 1. So this is showing the slope of 1. What we can see is that the actual slope here for the estimates and the true ones is below 1. And what it means is that the stereotypes are not extreme enough. So the more actually the actually very criminal groups like the Netherlands Antilles over here, some island in the Caribbean, they actually have a crime rate more than 4, but the mean estimate of them is 2.25 or so. So they're not extreme enough in the estimate. It's not far enough. And we can look at the accuracies again, and you are wondering, maybe you shouldn't take the mean to get the average estimate. Maybe you should take the median. But as you can see, actually taking the median makes the accuracy, the Pearson accuracy, lower. And you can take the trimmed mean, where you cut off, you take the distribution of data and you cut off the ends, and you use the middle 80%, and you can see this doesn't do anything different than just using the mean. And you can use a fancy approach, which we take the log values, and that is because if you take this scale, if you say this group is half as criminal, your value is over here. It's only half away from 1, and if you say they're twice as criminal, it would be over here. So the difference here in meaning twice as criminal or twice as not criminal, it should be equally distant from 1, but it isn't. However, if you log transform the data and then take the average and then log transform it back, then the distances are correct. However, as we see that doing this fancy scoring, it doesn't really do much of anything. In fact, it makes some things maybe worse. So what we see is that the SD error here is negative. It was way too low, and that's because the estimate here of the standard deviation is 0.5, but the true one is actually 0.99. So people were underestimating by roughly 50% the actual crime rate differences, or in this case arrest rate differences, between the immigrant groups in the Netherlands. And it didn't really change much depending on how you scored the data. And the people actually did slightly overestimate the actual crime rate here, but not by much. And it depends on how you score the data. If you use the arguably more sensible log mean approach, then they're actually underestimating it on average. But it depends a bit on how you transform the data, so this conclusion cannot be so strong. In terms of distributions of estimates, as you may guess, people don't exactly agree which countries are high in crime rates and which countries are low. So I picked 4 countries here, so and plot the distributions. And here you can then see that the stippled line shows the value of 1. So these are the people who think that this crime, the crime rate for this particular country of origin is average as compared to the Dutch, that is. And you can see most people in every case think these countries are average in crime rates. And then there's a difference in the tails. And so this one is, of course, the tail of people who think it's higher than average. Over here you have the tail of people who think it's below, and the same down here and here, and also higher here. And so taking the mean then involves getting a value maybe around here, depending on these. The problem also here is, of course, that some people may simply just be lazy, and they know we're not testing whether they're paying attention for every single country. There are some attention checks, and so if you just fill everything as like if you click every slider once to move it, then the survey data will be thrown away, because there are some countries where we ask people put the value at 5, and if they don't, then this data gets discarded as because they're not paying attention. But if you're paying a little bit of attention, you can still kind of press a bunch of 1s, and then once there's an attention check, you put that at 5, and then the other ones you put at 1, 2. So probably there is some proportion of people who did this, and that's why also why there's a huge cluster of values at 1 for the same country. So maybe this way we measured it wasn't exactly optimal. It's a bit difficult to say just from this study. Very interesting thing about the crime rate estimates is that they have a quite large pro-African bias, and the pro-African bias comes from taking the true crime rate. For instance, Morocco here is a true crime rate of roughly 3.7 or so, and the estimate is roughly 3.4. So the estimate is a bit too low. And you can do this. You can do the difference between the true value and the correct value for every country, and this gives you a new column of the deviation, which can be positive and negative. Which then you can relate this to this error to the countries. And so what you see is that the countries that have overestimated crime rates, these are the various Europeans or other non-Africans, and the countries that have underestimated crime rates, these are the various African countries. And the correlation is quite strong here, minus 0.43, and it's thanks to Peter Frost, who we see down here, for pointing this out. Peter was a reviewer of this paper, and in our study we had actually pre-registered the hypothesis to look at Muslim bias, because we previously had seen that there's a tendency of the Muslim countries to be have a negative bias, an underestimated crime rate. But Peter, he asked to get the plot for the Africans because it looks more like an African bias to him, and he is correct that the African bias is a lot stronger, and so the Muslim bias has maybe more to do with Somalis being Muslims and this sort of thing. We will do another study looking into this because we have some of these data from other countries, and there's an out-of-sample test there. So just to go over something, because every time you say that there's actually a pro-African bias, then you're going to say, no, that's just white supremacist science, it's only a meal, it's all pseudoscience, blah, blah, blah. So I did a little digging, and here we have a bunch of, well, I've chosen 3 papers with convincing findings that show that pro-African bias can in fact also be found by mainstream people. And here we have political science professor L.J. Zigarel, and he unearthed this collection of 17 survey experiment studies where a comparison of bias could be done for white people and for blacks and so on. And I think this is mostly about like mock trials, this sort of thing. So mock trials is when you give people a description of some court case and you give them some fake evidence and so on, you ask them to make a decision. And so, of course, if in the description of the suspect it can be black or white or Hispanic or Asian or something, and the people who have to make the decision, you can also they also vary, right? Because you can give the survey to different people. And what they find is, in fact, is that there's a small to moderate discrimination in favor of the black targets, and the sample sizes are massive here, so it's not a coincidence. And it's 17 different studies that were done by different people, in fact, and generally speaking, not published because you can see they got the wrong result. Here's another one from a few years later, or actually it's 1 year earlier, but these are older studies. But 2017 here, educational professionals at all levels show a pro-black bias in judgment. And again, the sample size 600 something. It's quite large. These are educational professionals, so it's difficult to sample these at large numbers. And still, here we have a replication of sorts. It's again by this Jordan guy, but the more interesting thing is that Brian Nosek is a co-author here. And for those who remember that Brian Nosek, he's one of the people behind this implicit association test, including the race version. And so he's been kind of milking this for millions of grant money. And even he can do a replication study of this study, I believe. And he shows 4,000 people in 6 studies. They still keep finding this pro-black bias in academic decision making, which is interesting, right? So here are 3 large mainstream studies that find a similar bias to what we see here. Going further, we can ask people, Dutch citizens, which immigrants would you prefer to have in your country? And specifically, there was a YouGov survey in the UK some years ago, and they asked people this question, and they gave people 4 options. And the 4 options are: you can have no immigrants from this country, you can have fewer, the same as currently, or you can have more. And I have plotted these data. The rank order is determined by the net positive, which is the proportion, the yellow and the green bar together. That's why it's neatly lined up here, because these are the ones where the net, none and fewer, so the net opposition. And so you can see that Somalia, maybe you cannot see, but Somalia is the country where people prefer the least immigrants from, which is not surprising since Somalis are the most dysfunctional group, I believe, in North Europe, aside maybe from the recent Syrians. And down in the bottom, which immigrant groups do Dutch people prefer? Swedes, New Zealanders, Spain, Austrians, Germans, Australians, and Austria, Janes, blah, blah, blah. Basically other Western dear fellow white people types. And so you can see that the preferences of the people are quite clear. It's just the politicians who won't oblige. We can go further and we can replicate a study done by Noah Kahl some years ago. It was one of those that got him fired. So of course, I think we should replicate the things that they're trying to suppress. If you fire someone for looking into something, I think of course we should study 10 times as hard. And so I've been trying to act on this principle. And here we have the correlation matrix, and the one you have here is the arrest rate, and opposition you have down here. So you can in fact see that the countries that have higher actual arrest rates also have higher opposition. 0.55 is the correlation. And if you look at people's stereotypes, which is what a policy would be based off, because people don't know the actual true arrest rates, but they do have an expectation, and if they form their policies on the basis of this guess, the stereotype they have, and this of course then correlates really high, 0.77 with the policy. So it seems like people have they form an opinion about the crime rates, because they notice they differ, they form an opinion about the rough differences between countries, and when asked to give their preferences by country, these mainly follow the average of these stereotypes, all totally standard rational stuff. And they're also quite opposed to Muslims. And if we do a mediation study here with a path model, and we have the arrest rate, you have the Muslim percentage, this is the stereotype crime rate, and this is the actual opposition. And so we see is that the effect of crime rate is mediated by the actual stereotypes, as you'd expect, which then go down here. And you can see that people are using Muslim percentage as a proxy for the crime rate to some degree, and this makes Muslims have a kind of an association with the estimates. And that's simply because if you don't know, for instance, the crime rate of some country, but you do know it's a Muslim country, you're going to guess higher than average, even if it turns out that maybe this country in particular are actually sending quite nice immigrants, but you don't know that because normal people don't go around looking up the crime rate statistics of 68 countries when doing some survey study. And so we can also see that they're opposed to Muslims beyond the effect of what they think is on the crime rate. But it is mainly through the crime rate. This path is stronger than this one. And so it seems that people they're opposed to high criminal immigrants, and they're also opposed to Muslim ones, even ignoring to some extent the crime rates. So maybe they think the culture is too different or whatever. So moving on to the next part of the survey, what about the sexism? And here we have this disturbing truth, as they say. We have the correlation between the estimates and reality, which is 9:4. It's an amazingly high correlation for a social science study. It is possibly the highest correlation I have seen in a long time. And based on these 54 units, and it's a bit hard to read down here, but it doesn't matter how you score these estimates, they all come out to 9:4. That is just the accuracy, which is amazingly high. Still, what we see is interesting, as you remember from the previous slide, that the slope here is the slope of 1. So that's the perfect calibration one, and whenever the actual line is the slope here of the orange one is lower than the slope of the perfect one, it means the differences are being underestimated. And we can see that down here is that if you take the standard deviation of the guesses, it's roughly 18, but the true value is actually 13.5. So again, the value of the differences between jobs and how many women and men are in different jobs are being underestimated to about 40% or so, which is quite much. So all those things you hear about how stereotypes are extreme and they're overestimating reality, as you can see, whenever these things actually get studied, you get the exact opposite conclusion. Both not only are stereotypes unbelievably accurate for many things like the occupation distribution, they're also underestimating reality. So it's exact opposite of what the social psychologists are telling us. So those people are full of shit. So, but we can say it's just the men, right? Right? In the Star Wars way. No, it's not just the men. Here we have plotted the ratings by men and women separately, and you can see the two lines are basically on top of each other. And if you do a regression model trying to see if there's any difference between these lines, you get that is not the case. Not only are men and women equally accurate, they're also equally biased in the sense of underestimating things. So men and women don't differ at all in their stereotypes, and so it's very difficult to blame men's stereotypes for holding women down, blah, 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 when women hold exactly the same stereotypes. Of course, any rational person would say stereotypes reflect reality, and that is also why they're less extreme, because stereotypes are not perfectly accurate, and so you get some regression towards the mean, and that is why the standard deviation is too low. It's very simple stuff. And the provinces, and so for the provinces, again, we get a very high correlation, 8.5 here, but we see something interesting. For the first time, we see that the orange line is actually above the perfect calibration line, and so the estimates are actually too high for the standard deviation here by some large amount. This is the first time I think I've seen this overestimation in a large study, and I would guess it has to do, remember, with how we asked the question, and I think people are, it's this one, they're just not used to trying to estimate this kind of average disposable income by province. And so I would guess that if we redid this study and instead asked people the average income of each province, and we gave people a like 0 to 10, where 0 is the least and 10 is the most, then this effect would kind of go away. But we don't really know right now. Nevertheless, the accuracy was quite high in terms of the Pearson correlation, 8.5. So these were all the average stereotypes, so the aggregate stereotypes as it's called, and or consensual stereotypes as they also sometimes call it. But we can also look at how individuals differ in their stereotypes. And here we have, let's go back to the crime data, and I plotted the distribution of these measures by person. As you can, we have some 600 roughly people who provided valid sets. If you're wondering why the sample size is not 650 up here, that is because 17 people provided the number 1 for every country, and when the number 1 is for every country, there is no variation in the estimates, and when there's no variation in it, you cannot calculate a correlation. There will be not a number or an A. And so that is why these 17 people are missing, because they are perfectly egalitarians, or more likely people very lazy on surveys. In any case, we see the distribution of the Pearson correlation is centered here. The red line here is the median. And we can see the median is roughly free, something over here, free. And so we can see that most people had some level of accuracy for estimating the crime rates, and there are some people over here in the left tail who have negative accuracy. And we've tried surveying some of these people before, and it turns out that they're kind of trying to combat stereotypes by answering opposite of reality. And so these are kind of like the Green Party voter, I'm gonna fuck up your stereotype type people. But when you use the median, then this tail doesn't really have much influence. You can see the median is 33 and the mean is 32. So there's too few of these people to mess up the stereotype accuracy. Interesting, if you plot the mean absolute deviation, so for each person, you can take their estimate and you can take the true value and you subtract these from each other, and you take the absolute value, you remove the negative sign, and then for each person, then you can take the average. How much do they get it wrong on average? And you get this distribution where on average people get the mean absolute error. They get it, the median is better. The median, they get it 0.8 incorrectly. So if the crime rate of some countries, for instance, is 3, that is 3 times the Dutch rate, then on average people will tend to be 0.8 off from this value. They will maybe say, so they will say on average 2.2 or 3.8 or this sort of thing, and for most countries, across countries, right? And there are some more statistics. I guess the standard error, so the standard deviation error, that is the tendency to over-underestimate things. And we see that most people are in the negative side, and that's because they're underestimating things. And so the median standard deviation error is a -3, and that is how much they're underestimating things on average. And there are some people who overestimate the actual differences between, but they're over here, and it's a much thinner tail than this big cluster over here. And the mean error, those are the tendency of people to, you can see it's negative here, the median is negative, and that's because people tend to slightly underestimate the crime rate. It is this value, the median here, and again we have a bunch of people over here who, so these are people who think like the crime rate for immigrants is going to be like 5, 5, 5, 5, and as we saw in the real data, often the crime rates are 2, 3, 4, but no country in these data have a crime rate that is 4 times as high as that is more than 400% more than, say, the Dutch here. And so some people who nonetheless estimated this, they get it, they're too high on the mean and they're too high on the standard deviation probably. Generally speaking though, we do see that most people are quite accurate. They don't get it much wrong on average, and the errors tend to be towards underestimating real actual crime rate levels, and they underestimate the difference between the origin countries. So getting into the more interesting part is where we relate this to intelligence. And so we can take the different measures we had before and we can relate this to intelligence, which, recall, we scored from 40 items. And so this is the average score. And so here we have these people. We can see that the correlation between having a Pearson accuracy on crime rates and intelligence correlates 0.2, which is respectable and highly significant because we have sample size of 600. A different way you can see is that if we instead measure it using the mean absolute error, and in mean absolute error you're counting any deviation from truth as bad, and so we're simply counting how much people deviate on average. We can see the correlation to intelligence is actually a bit higher, minus 0.3 here. The dot is on top of the minus sign here, but you can see the slope is negative. And you can see for the other things as well that mean error, the tendency to overestimate things, is also associated negatively with intelligence and also in the absolute sense. And so on this chart you want to be at 0, and so there's a lot of people here they're underestimating, and over here they're overestimating. When you take the absolute value as you do here, then you can of course not be below 0 since it's absolute value. And you can see once you get to the 130 IQ people, those are the ones over here, they don't get much wrong, right? These people are quite accurate in terms of stereotypes. Except when it comes to the standard error. What you see over here is that the right tail is actually, it has crossed the 0 line and is now underestimating real differences, whereas the far left tail and intelligence are overestimating things. and it just so happens the crossover is roughly here, and so the average is actually a bit negative. But still, we get the correlation is as respects. But once you take the absolute value, it is no longer significant. So because the smarter people tend to underestimate real differences, so these will be the elites and the intellectuals, you can see how this goes into explaining some of our cultural denial of real differences, that these are in fact what you see in these kind of data. I think it would be very interesting to redo this kind of study, but with actual PhDs and academics, and see if when you sample even more elite people than just sampling the top of random people, if this pattern replicates. I would guess that it does, and I would like to study that. More interesting, we can ask, is there a general factor of stereotype accuracy, a kind of a social perception general skill? And the answer is yes. This heat map shows the correlations between everything, and so what, for instance, you can see down here is that the correlations between Pearson accuracy is positive, so people who get provincial estimates, they're also slightly more likely to also get the occupation estimates correctly. You can see these values are very small. In a typical intelligence battery, like the correlation between two tests may be 0.5 or 0.6 or 0.4, and here we see that they're much closer to 0, but they are nevertheless not 0. And if we take the primary measurements, which are the Pearson correlation and the mean absolute error, and we put them into a factor analysis, and we get these set of loadings, and you can see that the Pearson correlations are all positive, and the occupation ones are all negative, or these ones are negative, because this having higher errors is worse, right? You want a negative value is better here. The reason we don't use the actual explorative factor analysis here is that the occupational Pearson correlation and mean absolute error has super high loadings. So in fact, this factor is mostly just taking the average of these two. And why is that the case? That's because, strangely, for the occupation, you can see the mean absolute error one here is correlated 9.2 with the mean absolute error. And that is not the case for the others, and that is why the explorative factor analysis is focusing in on this one dimension. And what we do over here is that we just take the z-score of these, so we standardize each of these values, and then we average that. And once you do that, you can correlate each of these back with the average you got, and that gives you these factor loadings, which made them less extreme than this one. And so these are the ones we're using, and this one is just for show here. And so we're interested in, of course, in theory, once you take more measures of stereotypes and you average them together, this should increase the correlation with intelligence. And this is exactly what we see. We have the correlation, the G factor up here, and we have the correlation with the crime rate accuracy, the Pearson accuracy. It's 0.2, as we saw. For occupations, it's 2.5. For provinces, it's 2.6. And for these other measures, the mean absolute error measures, they're negative and roughly the same values. And when you then take this one is the general factor of stereotype accuracy using the preferred method. It correlates 0.39 with the intelligence, which is quite high, right? And it's higher than any one of these alone. And so once again, when we aggregate data, some of the error goes out, and the composite has a higher relation. Interestingly enough, it looks like this, and as you can see, the blue line is a moving average type. It's the local regression, and you can see the error bars here. They actually deviate from the orange line here. The orange line is linear fit, and if you do a test of this, did I do the test? No. If you do a test of this here, what you find is that this deviation from linearity is actually significant. And so what it means is that as you keep going up in intelligence, stereotypes don't keep improving in accuracy. They seem to be roughly steady once you get to the 120 area, and then they may even decline in accuracy. And so that goes into what we were talking about before, that the elites up here seem to be kind of delusional, or at least not improving in the accuracy of stereotypes as you would expect them to, while over here they're actually they're falling much faster down here. So these are people who are completely unable to comprehend the instructions or have any sense of numeracy, and they have very poor stereotype accuracy skills. But the main increase is in this normal region from IQ 90 or so up to 120 or so. That is the main increase. It'll be very interesting to study these people. It's likely that it may have something to do with this pattern where the higher intelligence tends to underestimate real differences, and eventually this results in worse accuracy. So we didn't just measure intelligence in this study, we also measured education and age and politics and so on. And here we've only been looking at intelligence. And so the reader is now wondering which other things than intelligence predicts stereotype accuracy. Maybe intelligence is only predicting it because it's related to education, and education is the one that's actually related to stereotype accuracy. And here we used a fancy approach to answering this question. It's called Bayesian model averaging. And most studies, what you do is that you just take all the variables you have and you put them all into a regression model at the same time, and you interpret those results. And while you can do this, the results tend to be unstable because that many variables are correlated with each other and so on. A different way to get a sense of which variables are actually important in a given regression situation is that you can try a lot of models. And how many models can you try? Well, it depends on how many predictors you have. So for instance, if you have 10 predictors, you have a model space where in each predictor you can leave it out. And so that means you have 2 to the power of 10 predictors or models to try, and that is 1000. So you fit all 1000 models, and then you check which models give the best fits. And then what you do is that you average the results from the best models, say the top 10% or the top 5%. And this is what is displayed here. We have these geometric lines. These are some variable you're trying to estimate, say the importance of intelligence. You have 4 models that give estimates of this value, and the height of this probability distribution is determined by how likely the model is. So that is the model fit, say the R-squared or the BIC or some other measure. And so the best models, you give them more weight. And so the BMA is then essentially a weighted mean of the model estimates for some variable. Okay, so it's a bit much to swallow, but it's a very cool method, and you can read this paper that goes over it. So using this for predicting the general stereotype accuracy, we get this results. And here, what to learn is that PIP, that is the probability of inclusion of this predictor. And so what it means is that it is the proportion of good models that include this predictor in the model. As you remember, half the models include a given predictor because half them goes over there without it and half one with it. And so what we find here is that 100% of the best models in fact include intelligence. And the average estimate for intelligence in these is 36, and as you remember over here 39. It's almost the full effect, 90% or so, even when you control for all these things. So it seems like intelligence is mostly causal here. At least it's not mediated by any of these or confounded by any of these. And you can see the other things we measured. We measured many things that seem like they should be important. For instance, the time taken to fill out these. You may imagine that someone who spends a lot of time trying to estimate these would get things more correct on average, and it turns out that when you adjust for intelligence or whatever, this is not the case. This time taken is not included in the models. It has a mean estimate of 0. And age, you can see, was included in roughly half the good models and has like a slight negative explanation. The variable tilt is in a quarter models, a slight positive, and so on. The only other things that had a clear effect was education, which was roughly included in 2/3 of the models, but it has an effect size of 0.08, which is, you see up here, it is something like a quarter of the intelligence one. And, or is it a fifth? Something like that, between a quarter and a fifth. And first language not being Dutch, independent of intelligence, also has a large negative effect. I would guess that this one is because immigrants don't really know much, say, about these. They don't have enough knowledge of the country. They may have been only recently arrived there, and so that is why they do worse, even controlling for their intelligence level. And so these other things, basically, they don't seem to matter. Who you vote for, what your employment status, whether you're student, male, this doesn't seem to do anything. So that's what our foundings were on the relative importance of things. So it seems like intelligence is king when it comes to predicting stereotypes, and you should probably think of this general stereotype accuracy, as another sub-factor of the intelligence hierarchy. You know, there are verbal abilities, and there are, say, spatial ability. You have numerical ability, and so on. And you can also think of a general social perception ability, which would be very correlated with the stereotype measure. So to summarize the study, it is pretty much what you'd expect. We've been over this sort of thing before. Okay, for reals. Summary. We had yet another large pre-registered study, 615 people, provided data. They were from 2 different polling companies. We asked them to provide stereotype estimates for 3 different domains: immigrants, crimes, sex distribution in occupations, and provincial income levels. And we find that there are very high accuracies on average when you take the average stereotype, and non-trivial amount of average accuracy when you look at individuals. And in particular, the sex occupation stereotypes were extremely accurate at 9.4. Furthermore, we find this general factor of stereotype accuracy, and we find that it's also related to intelligence, and more so than the individual measures, which is what theory expects. We did not, educational attainment did not explain the intelligence relationship, and nor did any of the other 20 plus predictors we tried. Immigrant crime stereotypes are related to people's policy preferences in the totally obvious way. People prefer countries that send fewer criminals, right? That is just total duh stuff. And we find also evidence that people have both pro-Muslim and pro-African bias in their stereotype estimates. And so that may be reflecting some political thing, or it may be reflect bias that's actually coming from the media, when the media is feeding the people horse shit about the crime rates of Syrians or whatever. And then some proportion of the population who still trust the legacy media, they believe this, and then the stereotypes end up with this bias. Furthermore, of course, all the data and materials, the survey, blah, 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 in Dutch, if you want to go over it, it's all publicly available on the OSF. And with that said, I'm out of here.